Hello and welcome to this event, the festival tomorrow. Welcome to people who are joining us online as well. Apologies to in the room and online for the delay. We missed our first launch window, but we're just about making it to our second. Actually, it's just people getting across the site. So for those of you online who don't know where we are, we're actually in a site called the Science and Innovation Park, and that is part of the Science Museum Group. The Science Museum Group, as you know, owns is the Science Museum in London, but also they have a number of sites around the country as well. Tell me if I miss one. But we've got, is the National Museum of Science and Industry in Manchester, the National Rail Museum in York, the National Museum of Science and Media in Bradford. Then there's, I don't know what the full title is, Sheldon.
Locomotion.
Locomotion in Sheldon. Is that all of them?
Have we missed any?
I think there's just, and here. Yeah. So that's all of them. Got them all. Okay, so and the Science Innovation Park here is essentially the home of the Science Museum Group's collections. And what we're standing in now is the Hawking building, which is pretty much a brand new building, which was completed about 4 years ago, and then been a series of moving stuff in. So the people in the room, a number of them have been going on a tour behind the scenes. So we're really thankful and grateful to the Science Museum Group and the Innovation Park for letting us host these events here and letting people have a bit of a behind-the-scenes look inside this incredible facility. Footprint is about 6 times the size of a football field for this building alone. So it's pretty huge. And we're also, as part of this event, going to get a look behind the scenes or after hours down to the Science Museum in London. So I'm Rod Hebden. I'm the director of the festival tomorrow, which happens every year here in Swindon and online. And I'd like to introduce our first speaker, Doug Millard, who is from the Science Museum Group and is one of the space curators. So welcome, Doug.
Thanks, Rod. Great to be here again. First time in the dark, never before. Yeah.
Yeah.
40 years.
We nearly lost our speaker too. And then we're really, really pleased if the technology works. But we've got the live link up to Abbie MacKinnon. Yeah. Yes, there you are. Big round of applause.
Hi, everyone.
So Abbie MacKinnon is a space curator as well and is currently, I don't know if you had to kind of break in, but is in the Science Museum in London right now after hours once all the public have gone home. Welcome, Abbie.
Yes, thanks so much. It's great to be here. Sort of be there, you know. On screen, excited for the tour.
Thank you. Thanks very much. So, this is a kind of auspicious time to be doing this. So, thank you all for coming. Kind of over to you, Doug. So, why this event now?
Well, it's all about the moon. We're going back to the moon. So, what we're going to talk about, take some questions, is what we did first time round. Why we're doing it again. I say we. I mean, it's mostly America, but also Europe as well. And what that is actually part of, it's part of something far more ambitious indeed, which terminates on Mars. So that's what we're going to look at. It will be a part history, part what's going on now.
Got a clicker. You like to click?
I like to
power.
Click.
So what are we looking at first?
Right.
So hopefully not lose you, Abbie. You're going to be on screen regardless.
Whoa, there we go. Oh, perfect. Now, you can't see this, can you, Abbie? I don't think.
I can't, no.
Okay, so it's Gene Cernan. So we're going back in time to just before Christmas, 1972. I remember feeling very sad because it was the end of the Apollo program. So Apollo 11 had landed, July 69. And then Christmas 72, just before 72, the last mission. There were going to be 3 more, but they were cancelled by President Nixon. So here we have a nice picture of the last human to walk on the moon and to drive, as you can see. Gene Cernan, who passed away not that long ago, and he's standing by the lunar rover. And Apollo 17 had landed a place called Taurus Littrow, which was the sort of the uplands. The NASA scientists want to investigate the mountains. So that's the Apollo 17 insignia, logo, patch. And you can see, I haven't got a pointer, but you might just be able to see the names. We've got Gene Cernan, who was in charge. He was the commander. Then we have Ron Evans. He was the the pilot, the command module pilot, and then Jack Schmidt, was the lunar module pilot. So he was in charge of landing on the moon. And he was also the first and only scientist to go to the moon. Thinking of science earlier on. He was a geologist. Lots of geology on the moon. So, 54 years later, we're finally going back there. Not this time with Artemis 2, but we'll come to that. 2026, Artemis, the sister of Apollo, and there's the logo. And you can just, again, Wiseman. So Reed Wiseman is the commander. I always want to say Roger Glover, who was the bass player in Deep Purple. No, it's Victor Glover, who is the pilot. And then we have Christina Cook, pronounced Cook, spelt Koch, who's a mission specialist. And then Jeremy Hansen, who's Canadian. He's also a mission specialist. And this will be his first mission. Now, you remember the shuttle? Do you remember the space shuttle? Wings, reusable. It's Back to the Future, as you can see. So the picture on the left, it shows a Saturn V rocket. This was the huge rocket that took astronauts to the moon, 110 meters high, 363 feet. Those of you who know London, it's the same height as St. Paul's Cathedral. So a massive rocket. But, as we see on the right, with the rather boringly named Space Launch System, they didn't come up with a sexy name. SLS.
You just call it SLS, don't they? They don't even use the full name.
It's just SLS, right. Another acronym. Very similar. There are differences that we might touch on later on. So, Apollo, Artemis, very similar.
Are those the same scale? Or,
yeah, same.
No, not in...
Same scale. Yeah. And the tower, the red-coloured launch tower for the Saturn V, which they'd scrapped after Apollo 17, it was all cut up and chucked away. They've had to rebuild almost exactly the same device. Has anyone been to Florida to see the... Yeah, it's well worth, if you get... if you're able to, then go over and see the amazing facilities. So this is the building. It's called the VAB, Vehicle Assembly Building, Vertical Assembly Building. It's what they keep the rockets in when they're assembling them. And again, very similar. 54 years apart, but the building hasn't changed much either. I think they've given it a lick of paint, perhaps.
So, are they identical, or are there differences between them? They do look slightly different, not just the colours, but
Well, yes. We can actually, the photo on the right, you can see that the SLS has two rocket boosters, which are essentially giant fireworks. They use propellant that is solid, mostly aluminium powder. Once those are lit, off you go. It's just like a firework. Whereas the Saturn V didn't use anything like that. It was all liquid. Okay. So that's the main obvious difference. But a lot of the other capabilities very similar, which we'll come to, I think, in the next slide. So, the picture on the left, that's an Apollo command service module. So the cone at the top, the capsule, that's the command module, where the 3 astronauts were on the way to and from the moon. We have SLS, well, not the rocket, but the equivalent to the command module. They decided not to call it a command module. It's called Orion. But again, it's a capsule, almost the same. It's a Apollo capsule on steroids. It takes 4 people rather than 3. And then a service module, they've stuck with that name, underneath the cylinder. And that's actually the responsibility of the European Space Agency. So, there you go.
If you have questions along the way, we'll try and make sure we have time at the end, but there's something kind of burning. Do kind of...
Yeah, hang on to them.
Last slide, we could see an orange triangle at the top. Is that what Abbie is stood in front of?
Well, we're jumping ahead, but the answer is more or less yes. So Abbie's next to an Apollo command module in London, and the picture on the left, the command module is covered in blue protective layer, but yes, they're the same. And they come back to Earth in the same way as well, splashdown in the Pacific Ocean.
Stupid question then, which is kind of my role here. It was blue.
Saves me a job.
Yeah, I mean, I'll just show my ignorance. It was blue, now it's orange. They are the same thing? Was that just a cover they took off beforehand? Or is that something that's lost during the flight? What is that?
That's the point, yeah. So we'll see a picture later on of Apollo 10 at the moon, and it's beautifully shiny, and you can actually see the moon's surface reflected on the exterior of the command module. But when you come back to Earth, you're travelling very quickly, and Apollo 10 holds the record. Imperial measure, I'm afraid, 24,795 miles per hour. That's the fastest that humans have ever travelled. Until Artemis 2, they will come back faster. But in order to slow down, the spacecraft has to burn. Okay, it has this heat shield, which is essentially plastic. It burns off, and the movement energy is converted into heat energy. So it's all about, it's really a big break. It's how do you slow down, otherwise you die.
Which is a downer.
Which is a downer. So this is Artemis 2's trajectory, and we're going to go back to Apollo on the next slide. The point here is, I think I can move a little bit closer. So you can see Earth on the left, Moon on the right. You're launched from Kennedy Space Center. You do a few laps of the Earth, then you fire an engine which breaks you away from Earth's gravity, and off you go to the Moon. But have a look closely. You can see that, where are we? It's the green. So green is the outward journey, and you're just going around the Moon once. But you're flying past the Moon, okay? Albeit at a great distance. That's, by the time the Artemis crew are there, they'll be the furthest that human beings have ever travelled from Earth. But look at Apollo 8, and you'll see similarities, but actually Apollo 8 went into orbit of the Earth. It completed 10 orbits of the Earth, and I'm sure you'll be familiar with the wrong version of this picture on the right. So this is Earthrise. Now, we used to seeing it as a landscape, but actually what the three astronauts on Apollo 8 saw was this image, portrait if you like. So they were coming round the Moon, and suddenly the commander, Frank Borman, saw, will you look at that? I'm paraphrasing. Will you look at that? Isn't that beautiful? Look at that. Quick, get the camera. Bill Anders was with the camera. They had to find a colour film very quickly, and, produced probably one of the defining images of the 20th century. And the crew, you can look all of this up on, you can Google away. You can hear them, you can read the transcripts, you can see the pictures. They went to the Moon and learnt about Earth.
I think it's one of those real kind of pivotal moments, actually, just that first time humans looking back on the Earth. And they'd done it to some extent with the previous Apollo missions.
Yes.
But seeing the Earth rise, the way you see a sunrise, was, I think quite startling from the way they described it.
It was, and these are hardened professionals. You know, they had the right stuff. They were hard people. They had to react very quickly, and yet they were almost overcome with the beauty and the emotion of what they were seeing.
So, how does this compare to? So that's Apollo 8. So it did a slightly different manoeuvre because clearly you said it went in orbit, and Artemis 2 isn't doing that.
Yeah.
So there's quite a difference between how we've done, it took 8 missions to get that far last time. We're doing it in 2.
Yeah.
But they did it in a ridiculously short period of time, whereas we're kind of going a bit of a gap, time-wise. What are the reasons for that? Or why are those sorts of differences, do you think?
Well, we come to whether Artemis is a race now. I think it is. But back in the 60s, this was racing the Soviet Union to land an astronaut on the Moon first. And so the missions were concertinaed. It really was a race. So Apollo 8, this was Christmas 68. They landed on the moon, Apollo 11, July 69. So 8, 9, 10. So they squeezed 2 more missions in before the actual landing. This time around, we come to it later on, the landers haven't been fully developed yet. So there's going to be a long delay before Artemis 3. And at the moment, there's no need to go into an orbit. It wouldn't be risky, but it's something that they don't need to do. So if you don't need to do it, don't do it. Love this. So the 3 crew, they read each passages from the Bible, Genesis. And then Frank Borman said, and from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth. That's pretty cool. So, Artemis 2, and I think, not quite. Nearly there, Abbie, nearly Abbie. So Artemis 2, as I said, is part of this long program, eventually culminating in Mars, landing on Mars. And this just gives you some of the techniques, the projects, landing, space station, rover there, communication system, all the things that are required if you're actually eventually going to go to Mars.
That's the kind of key bit for where the UK comes in, isn't it, with the gateway?
Oh, that's the point, yes. So the UK, principally Surrey University, or Surrey Satellite Technology Limited, they're producing a communications satellite network for the moon as part of that infrastructure.
So when we finally get, NASA go back to the moon,
Yeah.
actually they're using British Telecom, really, because it's going to be the UK controlling that kind of communications.
There'll be a little Union Jack.
There we go.
Yeah.
So, we can kind of occasionally switch it off and on just to wind them up.
So very briefly, because it's time we hand it over to Abbie to talk to us about some real spacecraft. President George W. Bush, 2004, a year before the Columbia shuttle had disintegrated, the program was stopped, and Bush ordered NASA to go back to the moon using a similar concept to Artemis, but it's called Constellation. President Obama cancelled Constellation, and actually, here's the irony, he ordered that some of NASA's activities should be passed to private industry, so the likes of SpaceX and people like that. So, present day, President Trump, I mentioned it's a race again. America is racing China, quite clearly. So it's a question of who gets there first. And what Trump doesn't want to happen is that. And it's not quite right, because it'd be the South Pole we want to land. So
we weren't going to criticise the accuracy of your image there.
Yeah. So there we go. I think, Abbie, you've been very patient. Are you still there?
Yep, I'm still here. No, that was great. Thank
Okay.
you.
Over to you. Talk about this. I'm showing a picture of Apollo 10 at the moon. Over to you.
Awesome. Yes, I can actually see the screen now. So I will not bore you with my face for too long. I am standing in front of the real Apollo 10 command module. So I'll just swing you around. I'll also just say that while the museum is closed, it is still a very active place at night. It does tend to come alive in a different way. So there might be people toing and froing and some noises, but it should be fairly quiet. So if I turn you around, and now you can see Apollo 10 in all of its glory, the same exact sort of reddish rusty color as was on that image that you showed, Doug, after it landed in the Pacific Ocean. So Apollo 10 was the dress rehearsal for Apollo 11. So while we talked about Apollo 8 happening in December of 68, Apollo 10 happened in May of 1969. This crew did everything except actually touch down on the lunar surface. So the lunar lander was taken to about 14 kilometers above the surface of the moon. So it must have been very tempting for those the 2 astronauts to not to just go the whole distance and be the first. But they were far too well trained for that. This object has been pretty much continuous display in the Science Museum since the late 1970s, when it came to us from NASA and the Air and Space Museum in Washington, D.C. So while it is Air and Space Museum's object technically, we really think of it as our own and look after it as if it were ours. This new space gallery opened in September of 2025, so just not that long ago, and so some of this stuff is been redisplayed in a way and features that have never been seen before. So I will take you kind of around. It's very slightly disconcerting seeing all of this on that screen up there. But Doug talked about the heat shield. So I will give you, hopefully, a nice view of said heat shield. So this, as Doug said, you come in pretty fast and hot back into the atmosphere on your return, on the return to Earth. And there, the command module and Orion's heat shield for the Artemis program is very, very similar to this one, to the Apollo heat shield. So it's an ablative material. So as it burns and heats up, it breaks away from the spacecraft, which takes the heat then away from the spacecraft and helps to keep the astronauts inside from burning up. Now you can see all of the scorch marks and things. Now I think lots of this is to do with re-entry through the atmosphere, but some of this is also just damage that's just happened over time because the material is so kind of friable. So it gets touched and it does kind of sort of turn into a bit of like a powdery dust. So we have to be very careful when we move it around. I will whiz through a few other Apollo era objects that we've got on display as well, and hopefully it's not too much glare from the glass. But here we have three objects, which are Apollo sort of astronaut items. Now, the most significant one is that one in the back, which maybe if I come at a slight angle, you'll be able to see a little bit better. That one at the back is a headset, and this is Neil Armstrong's Apollo 11 headset, the real one. His DNA is on that headset. This is has been on loan to us for quite some time from the Air and Space Museum in Washington, D.C. The other two objects are the one on the right is the Apollo survival radio. So this, all of the command modules had fitted in them these radios, which the astronauts could use if they landed off course or not in their intended location, and allowed them to kind of rendezvous with hopefully friendly people. And then the other one to the left is a Omega Speedmaster watch. This is the watch that was sort of the NASA-approved astronaut watch. So it underwent lots of testing, but you can see how big it is, hopefully, how big it is. It has Velcro, so that astronauts could wear it both on their wrist, nice and tight and snug, but then they also could wear it on over top of their big spacesuits. If you can see this image here, you can see Jack Swigert nicely modeling that on his wrist. Now, this watch was not a flown watch, but it is a real one that was donated from the Omega company. Now, Doug can speak quite a lot about this object here. I will let him add anything that I've perhaps missed, but this is an Apollo simulator control panel. I'll get up close to it so you can hopefully see some of the detail as I speak. But all of the astronauts had to train on simulators for the Apollo program. We'd never been to the moon before, so there had to be some way to train the astronauts without actually taking them to the moon, so that they knew how to operate the spacecraft and get home safely. And so this is an identical control panel to all the control panels that would have been in the real command modules. And this, you might be able to see, if I hold steady for a minute, that there are some handwritten notes and equations and things that the astronauts would have put on during their training to help remind them of things as well. if you come to the museum one day, you can have a really close look at it and see what some of the switches mean. Like, for example, we have some switches here, which are, you can see hopefully with the yellow and black stripes over the guards. These are switches that you absolutely do not want to accidentally switch with your knee or an elbow or a big glove. So that one in particular that hopefully you can see with the stripes is says CM/SM SEP, and that means Command Module Service Module Separation. You absolutely do not want to switch those until you absolutely have to. So yes, this is an incredible object, which we're really excited to have on display here at the museum as well. And then I will hand back over to. I'll make sure Doug has to make sure I haven't forgotten anything. We talked about the service module a second ago. And so this object here would have sat inside the service module. This is an Apollo fuel cell. So the service module, and Orion has one as well, which was made by the European Space Agency. The service module is critical. It's the bit of the spacecraft that's attached to the command module the whole way to the moon and back just before re-entry, which provides all of the power and heat and electricity, and in this case, water for the astronauts. So this there were 3 of these fuel cells in the service module for the Apollo missions. This is actually British technology. This was invented by Francis Bacon. He got a personal thank you from President Reagan, Doug, or have I got the wrong president?
Nixon.
Can you remember? Nixon. Nixon gave him, a personal thank you for his contribution to Apollo program, which is quite incredible considering that it is very much an American-led program. But yes, these fuel cells provided all of the electricity, power, and heat to the spacecraft, and also the water, drinkable water. So this is also 2 out of 3 of these failed on the Apollo 13 mission, which famously had the oxygen tank exploded, fuel cells failed, and what was meant to be a, dare I say, routine moon landing ended up becoming really a survival mission to get these 3 astronauts back to Earth safely, which, of course, they did. If you haven't seen the film, I watched it recently, and it was amazing. I think I'm going to run over to one more object. I won't run because that's not safe, but I will walk quickly to show you. You were talking about the Saturn V rocket, which launched the Apollo spacecraft to the moon. This is the J2 engine, which was on the 2nd and 3rd stage of the Saturn V rocket. So there were 5 on the 2nd stage and 1 on the 3rd stage. And now the 3rd stage, was quite critical because this was the stage that ignited for translunar injection. So TLI, which is when you have an engine burn, which sends you on the trajectory to the moon. And this is the engine that did that. So really, I'm not sure if you get quite of a sense of scale. If I can get a label or something in the foreground, you can kind of see how big it is. But yes, Doug, have I missed any critical Apollo objects for the moment? I don't think so.
Thank you.
That's great. Thanks, Abbie.
So I'm sure the scale when you're there must be immense. It looks huge from here, but I mean, it's one of those things you have to see the thing in person, don't you? And you touched on there that the gallery's only just been open, and I think I failed to mention earlier. I mean, the Space Gallery. I haven't seen this yet, and I've been to the Science Museum a million times. The Space Gallery that was there before. How long was that in place? Do you remember, Doug?
86 it opened.
So that's been there for quite some time.
40 years.
A mere 40 years.
Yeah, nearly 40 years. Yeah.
So the Space Gallery was there 40 years, and they've just completely stripped and a complete re-display in a new gallery, Destination Space. That opened in September. So I think we're really lucky to be able to get a glimpse of that because very few people have been down and seen it yet. So thank you for that, Abbie.
Great.
Yeah.
Thanks, Abbie. And as Abbie's, you could tell she was walking around. So even some of the objects that have been displayed before, now you can walk around them, so you can see them in much closer detail. Is it me now, Abbie? I think it is.
Over to you.
Okay.
I think so.
Right. Clicker time.
Clicker time.
Clicker time.
Yeah.
Be back in a minute, Abbie. Right. So we're obviously focusing on the moon today, but we shouldn't forget everything else that's gone on as regards human spaceflight. So this is a depiction. Everything is to the same scale, and it's essentially the story of space stations. So top left, you have Salyut 1. So the first space station was a Soviet one, Soviet Union, back in the early 70s, 71, I think, something like that. And as you can see, just right of centre top, Salyut 7. Salyut 7, I think, was the one that had another great story when two cosmonauts had to fly up to an abandoned Salyut space station and bring it back to life. Extremely dangerous. We don't hear so much about that. It's a great mission. Then back to the left, you can see Skylab. And you might recognise bits of it look like a rocket, because that's exactly what they are. So you had unused Saturn V rockets once Apollo had been cancelled. So the second stage of one of those rockets was used to form the bulk of the Skylab space station. Another great program we tend to forget about today. Bottom left, my favourite of the lot is Mir. So that's the Soviet space station. Mir meaning, depending on your choice, either peace or snow, one of the other. And just at the moment, I'm reading the biography of an expat British astronaut, Michael Foale, who was on board Mir when there was a collision. And it's another really hairy story, but fortunately everyone came back safe and sound. And then you can see the shuttle down at the bottom, and the shuttle and Salyut 7 are enveloped by the International Space Station, which of course, if it wasn't raining, I don't know, might be able to see it tonight, but the ISS, the biggest thing that's ever been assembled in space, when the weather is kind, once you check on the timings, you can see it pass overhead. What's next? Next is, yes, so we're getting ready to go back to Abbie, and this is a picture of the Principia mission.
Is this taken from the International Space Station? Is that where we are?
Yeah.
Photographer.
So,
Okay.
we're aboard the space station, and we're looking at the spacecraft that took Tim Peake, Yuri Malenchenko, and Tim Kopra, the only time two Timothys have been in space at the same time.
Truly historic moment.
It is, yes,
Yeah.
yes. Record book time. A beautiful picture of the Earth again, but and you can see Soyuz in Cyrillic. They don't have S in the Cyrillic language, Soyuz. And then I think, are we out of sync there?
So I think then you were going to go back to Abbie, in fact.
I think we've missed. I know. It's because the cue cards have gone.
The cue cards have
Right.
gone.
So,
Yeah.
Abbie, can you hear?
I'm here.
Yes. It's Soyuz time.
It's getting to a bit that more of us will remember now, because we all remember Tim Peake's mission pretty much, I reckon, in the room. And the National Trust here sent some seeds, and it was a lot of people have memories of Tim Peake. So what have you got in the museum now?
Yeah, so I've just whizzed out just outside the gallery, so you can get a kind of sense of what the sort of approach looks like. But in particular, I wanted to make sure that you guys all got a chance to see the amazing parachute. So this is the parachute from the Soyuz spacecraft that brought the Tims and Yuri Malenchenko back to Earth after their trip on the space into the to the International Space Station. So you definitely have to come and see this in all of its glory. It is enormous. Also, I will get to the side here as well. You can see it goes up again as well. Try not to drop my phone on my head. But yes, quite a lot of effort put into untangling all of these strings as well by our conservation team at the time of install. So yes, and then we approach and we get to see the actual spacecraft that was just on the screen. This is the Soyuz descent module that yes, astronaut Tim Peake flew to the International Space Station in. Now that big window that you can see, and I'll hold you up a little bit so you can hopefully see in a bit. That is not a window that would have existed for the astronauts. It's one of the parachute hatches, but because it sort of gets blown off with the when the parachute deploys, a perspex window was put in so that visitors could see in much better than through what the astronauts would have used, which is these little portholes on the side. And much like the Apollo 10 command module, you can see the kind of scorch marks, especially right here. You can really see the scorch marks of the heat from re-entry in through Earth's atmosphere. So incredible. We also have a video actually on our YouTube channel of that we did recently of Tim Peake actually going back into this capsule, which is definitely worth checking out. But yes, and Doug said 360 views, so we can go kind of all the way around here as well. So I think as well we talked about Tim Peake, first British European Space Agency astronaut. We have to be very particular about our wording here because we also have on display this spacesuit, a Sokol spacesuit, a Russian spacesuit, which was worn by the first Briton in space, Helen Sharman. So you can see, got a little feature of her next to her spacesuit as well, also wearing it. So this is, so Helen traveled to the Mir, Doug mentioned the Mir space station, the Russian space station, in 1991. And this was in a time period where Russia was trying to kind of, open their borders and have a more kind of international effort happening. And so part of this kind of opening up involved inviting astronauts from other countries up to the space station. And so Helen heard a call on the radio for looking for, British citizens who wanted to be an astronaut, and she applied, and out of thousands of applications was chosen. And so we're really lucky to have this suit here on display. And it's undergone some conservation work by our amazing conservation team and new mount and everything to help kind of protect it and keep it going for a long time. Nice view from the side as well. So yes, I think back over to you guys, unless I've forgotten something.
I think that was it.
Thanks,
yes,
Abbie.
It's like a game of tennis, isn't it?
It's a real. I think there's a kind of shock of the when you describe that, how Helen ended up going to space, because you kind of think astronauts go through all this training and their whole career, but she just heard a thing on the radio and said, "Oh yeah, I'll do that." What was she doing? Basically, had to be trained, but until that point, she had no idea that was the direction of her life.
No, she's a chemist. So she's working in several companies, including a well-known confectionery company. But she was essentially working in a chemistry laboratory, and she was driving West London and heard this advert on the radio. The rest is history.
Yeah, it's not the usual advert you kind of hear and respond to on BBC Radio Watcher.
No.
So yeah.
Okay.
So yeah, where are we going next?
I think it's
from Soyuz.
So we'll just park humanity for a bit. Human beings, very expensive to put into space, and increasingly you can do an awful lot with robotic craft. Don't worry about looking at everyone. This is another cue for Abbie. And these are some of the famous robotic explorers from over quite a long period. So top right, you might be able to see New Horizons. So that wasn't that long ago, but that flew past Pluto and returned the first detailed pictures of Pluto, and is now hurtling towards the exit of the solar system. Then we've got Rosetta, just sort of at, where are we, 7 o'clock. So New Horizons, 7 o'clock down to Rosetta. And that's the wonderful mission which went to a comet released a little lander called Philae and landed on a comet. How amazing is that? That's totally astonishing. And there are various other ones. We've got a window here looking at the various Mars rovers. But I want us now to move top left almost, well, second down, a spacecraft called Bepi Colombo, named after the scientist, the Italian scientist, Giuseppe Colombo, who realized that you could actually steal the gravity from other planets in order to explore the solar system. And Bepi Colombo is doing that at this very moment on its way to Mercury, which should arrive later this year. And Abbie, have you heard of Bepi Colombo?
Oh, yes, I think I have heard a thing or two about Bepi Colombo in my time here at the Science Museum. In fact, I've got a 1-to-1 scale model of Bepi Colombo just behind me. Now, you can sort of understand the scale. I can't actually get it all in the shot, so I will turn you around in a minute so you can see it a little bit better. But it is a monster of a spacecraft. I'll try not to show you the diner, which is not that interesting. There we go. And so this spacecraft, it says 1-to-1 scale, as I said. Oh, it goes all the way up. And it is a 2 spacecraft mission to the planet Mercury. It launched in October of 2018 and is still on its way. Doug mentioned the stealing the gravity from other planets, and that is one of the reasons why it takes such a long time to get there. Mercury is so close to the sun. The huge gravitational pull from the sun means that the spacecraft really does have to do quite a lot of braking and slowing down on its way. And one of the key ways of doing that is by doing gravity assists around Earth, Venus, and Mercury itself numerous times before being able to settle safely into orbit around the planet. Now, this is what we have on display here is the structural thermal model. So this is a engineering model which was used to test the structural strength of the entire spacecraft. So the strength needed to withstand all the vibrations and noise at launch, as well as the thermal protection that the spacecraft needs in order to withstand the extreme temperatures on the way to Mercury. And at Mercury, the spacecraft will experience temperatures of minus 190 degrees Celsius all the way up to a maximum of about 400, maybe even 450 degrees Celsius. So the spacecraft has to both stay warm in the cold, but also stay cool in the heat. Not an easy task. Yes, so this is that model. That was exactly what this model was meant to do. We got it on display just before Bepi Colombo launched, and we're really excited to have it on display when it arrives at Mercury in September of this year. So watch this space for, I'm sure, some events and things happening here about this. So the 2 spacecraft I mentioned, so let's get it in shot. So that one with the kind of satellite dish or the high gain antenna on the side, that is the Mercury Planetary Orbiter. This is the European Space Agency's orbiter, which when it arrives at Mercury is going to go into an orbit which is going to allow it to look at the surface of Mercury, the kind of makeup of composition of the planet. And then that, what I like to refer to as the Elizabethan collar, is a sun shield. And tucked inside that sun shield is a Japanese orbiter, which is looking at Mercury's magnetic field. So it's going into a separate orbit to the European spacecraft. So really complex kind of choreography when it arrives at Mercury, where these orbiters will need to separate and go into their very separate orbits to examine all the different elements of both the planet as well as the magnetic field. So really exciting, and lots of technology on this spacecraft developed entirely for this mission. This bottom module here is the transfer module. This object's entire existence is just to get the 2 spacecraft to safely to Mercury, and then its job is done. Same with the sun shield that protects the orbiter on the journey, but then the orbiter itself has got its own protections once it's in orbit, and so that sun shield is again no longer needed. So yes, I think that's probably the gist. Why don't I go back to you guys, and then I'll sort of slowly walk around so people can see.
Thank you.
That's great, yeah. It's a great picture. It's your phone, isn't it, Abbie?
Yes, yeah, it is.
It's amazing.
A bit dark over here.
Okay.
In terms of scale, Doug, 'cause you've seen this, I mean, I'm trying to get a sense. I mean, it looks to be like a kind of bus size standing on its end. Is that about right?
Yeah, about yes, a slightly shorter single-decker bus.
Right.
Yes.
Okay.
Yeah.
I mean, it's kind of huge. And those models, I mean, it's kind of, call it a model, but essentially when they do these missions, they build multiple of the thing perfectly because they want to test the hell out of one and not the one they're actually going to send into space. So it's essentially the real thing, but not sent into space.
It's the real thing, except it doesn't get launched, but it is shaken because a rocket launch is extremely violent, and then, as Abbie was explaining, it is baked and it's frozen to make sure that the spacecraft and its systems can survive the extremes of temperature. So really nice shots there, Abbie. Excellent.
Oh, good. Thanks.
Right. Okay, you can rest for a bit, but we're back in a minute. Okay, the United Kingdom is doing space like it's never done before. We do have a long history going back to 1957, actually, same year as Sputnik, the very first satellite, was launched.
Year after Eurovision?
Yes. Nice one. But we've been a little reticent. We didn't do human spaceflight officially until Tim Peake's mission. Helen Sharman's was a present from President Gorbachev, essentially. But now there are all these new companies springing up. You see, all around the UK. We hope to be launching rockets from Scotland soon. Never been done before in Europe. Orbital rockets, rockets that will put satellites in orbit. And then if we go down towards, let's see, Wiltshire perhaps, or maybe Oxfordshire, we have a centre called Harwell. There's an aerial picture on the right. It's an old World War II airfield. It was then turned over to nuclear research. Now it includes a lot of space research. So again, looking at heaven there just to see what's going on already. And they have open days as well, so go and have a look. So the European Space Agency, you can see, has a site there. And then we have some of these new companies. And I think we're immediately lobbing back to Abbie.
Yeah,
that's right.
Kind of,
So
one of the things we were talking about earlier is that we're really close to them, but also people might remember the UK Space Agency, when it was founded here in Swindon. And there's still an office there now, although most of the staff have kind of moved to other parts of the country, including Harwell. So it's kind of grown massively, industry, as a result of recent work. So
now we've got Abbie who's going to talk to us about some of these new technologies. Over to you, Abbie.
Yep. Thanks so much, Doug. Thanks, Rod. So I'm Doug mentioned Harwell, so I figured I should start off with some objects that we have from a company based in Harwell. So this is a company called MagDrive. They are working on developing some new thruster technology. And this thruster technology uses solid metal as fuel. So earlier in the talk, Doug mentioned liquid hydrogen, liquid oxygen. We've talked about the solid fuel. So this is a different way to generate thrust, which does not involve any solid fuel or any liquid hydrogen or liquid oxygen, but in fact involves a solid piece of metal, and that is not a fancy piece of metal. There's lots of different types of metal that they can use, and what they do is they send pulses of high energy at this. I mean, I imagine sort of a laser beam. I'm not really sure that's technically correct, but I think visually it works. So sending these high pulses of energy at the solid metal, which generates a plasma, and then magnetic field is used to eject that plasma electrons. I think I don't know. Doug can probably explain the actual the actual process a bit better than I can. But essentially, that's what generates the thrust. And here we have 3 prototypes that the company developed. So a bit like Bepi Colombo, especially with new technology, you're always people are always trying to test out, proof of concept theories, and then there's scaling up and scaling down, lots of testing and things that need to happen. And so this is a really nice example of that. So on the left-hand side here, we start off with what was essentially the proof of concept. Can you generate plasma? Can you kind of generate enough energy at a bit of metal to generate plasma? And this was done in the founder of the company, Thomas Clayson. He did this experiment in his daughter's bedroom during COVID in 2020. So this is, really, a really rough kind of experiment, so to speak. And then, one of the next versions was this kind of adding in, taking that concept and trying to put it into something that might fit inside a box and incorporating a computer that would run it. And then I'm skipping a few steps in here. And then you end up with what is essentially the finished product, which is, something that is a very nice size that can be attached to the satellite. And this would be for satellites in low Earth orbit. The thruster would allow them to move quite quickly and be quite adept at avoiding things like space debris or moving to a different orbit. And the company's long-term vision really is their thinking is, well, metal is widely available in the solar system, so theoretically, eventually, spacecraft who have use metal as fuel will be able to refuel in space, and so that's a real game changer and something that lots of companies are looking at different things to do with refueling in space. So yeah, some really cool objects there.
Abbie, I'm going to jump in now because there's lots more to see, but we're almost running out of time. So I think we've got to leave some time for questions, but there is certainly more to see of all of this new technology that's being devised and developed in this country. So
while we grab the microphone and people start to think of questions, I've got one question online, which is, do you think the Rosalind Franklin Mars rover designed by ESA, the European Space Agency, will ever get launched to Mars, given the modern technological advances that has happened since it originally was meant to launch?
Is that to me or to Abbie?
Whoever wants to take that question.
It's going to be launched, definitely. You don't go to all that trouble and don't launch it. Originally, the Americans were going to launch it. They pulled out. Then the Russians were going to launch it. We know what happened there. So, but I think, Abbie, a launch vehicle has been found. I suspect it belongs to a company whose owner has the initials EM. And I think it's not that far. It depends where Mars is. You have to wait until Mars and Earth are in the right positions. So. Yeah,
and my understanding is that they got the funding at the most recent ESA ministerial to press ahead with Rosalind Franklin. So yeah, I do. It will go.
Okay. Any questions in the room? Yes. Could I wait for the microphone to come to you, Chris?
It's like question time, isn't it?
It's more of a general question about space exploration. There's all this competition between countries to race back to the moon and the original space race. Would it not be ideal if everybody worked together? And if there has been, other than the ISS, has there been collaborative projects where countries have worked together for the benefit of the world, not just the country?
It's a kind of broad question, that, and there's obviously lots of international collaboration, but yeah, do you want to tackle that?
Do you want to do that, Abbie, or shall I?
Yeah, I'm happy to start us off, and then Doug, you can chip in. But yeah, I mean, I think I think I think when we have examples of international collaboration with space missions, of which the vast majority are international collaborations, I would say, especially the planetary missions and things now. I think it's a much better sort of situation But, I guess we are where we are, but lots of examples of international collaboration on lots of different types of missions. I mean, even Artemis, we talk about it about it as a NASA program, but there's a lot more international input into that program than there ever was with Apollo, for example. So there are changes that have happened, but yeah.
Yep.
Yeah. Any other questions in the room? Or should we see some more objects? I'm going to just check any more online.
We could bring up the slide of...
So could we have the microphone down here, please? Thank you. Yeah.
I remember when Beagle was a big race to take off at a certain time, and I sort of remember it had to take off by 2003 because that was the time Mars was going to be closest to the Earth. When will Mars be back?
When will Mars be back?
In the same...
Oh, I don't know. I'd have to Google that. But it's a cyclical thing. So is it every 26 months, something like that? I mean, you can get to Mars at other times. It just takes a long time. So certainly for humans, you don't want to spend any longer than 6 months. So the relative positions of Mars and Earth are crucial. 6 months to get there, that's the quick route. You then have to wait 6 months for the planets to realign on Mars. You have to wait on Mars, and then it's 6 months back. So Apollo was amazing, but it was just a paddle at the shoreline. Going to Mars will be orders of magnitude more difficult.
Is that alignment, though? So 26 months, there's about 2 years you have to wait in between.
Something like that, isn't it?
I think that's right, yeah. And Beagle, of course, was a little British mission stuck to the side of a European mission, which was kind of ExoMars, which was going anyway. So it was kind of, I think it was, there's lots of international collaboration, but there's also these kind of funny little odd ones. But I think there's a real kind of proof of concept in what Beagle did.
Oh gosh, yes. And of course Beagle 2 did make it to land on Mars. The first European mission to actually land, and British, to land on Mars. Thing is, it never phoned home. It never told us it had landed. And it was a NASA spacecraft that actually spotted it and said, there it is. There it is.
Thank you. Any other questions? Yes? Just down here, please.
I know this isn't really about like Mars or the moon, but like we've been sending spacecrafts to explore Mercury, Venus, Mars, Jupiter and Saturn, but when will we get to explore more further bodies, like not just the ice giants, like really way beyond, because we are really close to the sun. There's much more beyond that. There's dwarf planets, Oort-Cloud, Counterbot. How long till we explore all that?
Yeah, Doug, where's our ambition?
Yeah, well, the sky's the limit. You said it. I mean, there is an awful lot beyond there. The problem is space is very big. I mean, it really is very, 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 very big, which means the distances are huge. It takes a long time to get there. So you're absolutely right. At some point in the future, we'll probably have flotillas of small spacecraft, constellations, going to the outer extremities of the solar system. But that will take a long time. And the signals, when we try and communicate, it will take a long time for the signal to reach the spacecraft, even traveling at the speed of light, and similarly for the answer to come back. But you may have heard of the Voyager spacecraft. If you haven't, then Google away. And there are 2 Voyagers, Voyagers 1 and 2. They went past the planets, the gas giants, like you said, and then they've kept going. And scientists are still communicating with them. And the power of the signal is minuscule. Absolutely tiny. It shows how astonishing space science can be.
How long have they been flying? When did they launch? Remember?
77, I think. Anyone know? 1977, I think. Yeah, and they went past someone said yes. So, and they're still going strong. Amazing. Absolutely amazing.
Yeah, and I think we sometimes thrown by the pictures of we see the diagrams of the sun and the planets all lined up, and they all look pretty close together, and they're very, very deceptive. Is it sort of travelling at the speed of light to get to the sun takes 10 minutes, something like that?
Nice.
So the distances are pretty far.
Yeah.
But yeah, the Voyager, we then put messages to aliens in case they find Voyager on the side of it, including
I don't know.
Johnny B. Good was on the side of one.
Yeah, Chuck Berry. Yeah.
Chuck Berry's on the record on the side of it. Really helpful for cultural exchange purposes. Abbie, you were going to jump in, I think.
Oh, yeah. I was just, as Doug was talking about Voyager, I just wanted to, we didn't get a chance to talk about this engine, but this is RL-10. This is another liquid hydrogen, liquid oxygen engine, but this engine is quite amazing. It's been in operation since the 1960s, and it was the engine that ignited to send Voyagers 1 and 2 on their journey. So this engine has sent spacecraft to every single planet in our solar system, and of course Voyagers 1 and 2 now both in interstellar space, furthest man-made objects ever. So quite incredible. But yeah.
Thank you.
And SLS?
Yes, and of course, well, that brings us nicely back around to Artemis and SLS, because this engine, a version of it, will be the engine that burns for the translunar injection for the Orion astronauts on Artemis, Artemis 2 and all the future Artemis as well. So the same purpose that the J2 was for Saturn V is what the little RL-10 will be for the SLS.
Amazing. I think we are out of time. We've got one more question from online. So it's kind of getting the idea that it seems you can see practical purposes for going to the moon and everything we're going to do there. But the question online was, is there any point to sending humans to Mars apart from ego? The implication of that question is that ego is also a good reason, so I don't know.
Well, I can take the approach of Sir Humphrey from a TV series called Yes Minister and Yes Prime Minister, and so I couldn't possibly comment. It's a big undertaking. I don't think it's going to happen anytime soon, and it's going to be costing an awful lot of money. So you can make your own minds up about.
Do you think so? I guess the point you're making is you'd have to have a very good point to achieve that, because it's would be ridiculously expensive and very hard. If we could do it, is there a value? We've sent robotic missions there, which are doing interesting science. Is there a good reason to send humans to Mars?
It'd be interesting to see what Abbie says, but I think we always have to remember the space age opened quite recently, 1957. I was -1 years old. It's well within a lifetime. And when you look at everything that's been achieved, you have to start thinking, a few centuries in the future. If we get our act together and sort out all the problems that need to be sorted, then if we're still exploring space in 2 centuries' time, then probably make a lot of sense to go to Mars.
Abbie, any thoughts?
Yeah, I get this question a lot, and I'm sure Doug does too, about, what's the point of sending humans? Isn't it too dangerous? I think there's a few different answers that I like to kind of give. I think robots, as much as incredible as they are, and as much as they can accomplish, they are not really a replacement for humans. Now that is still not necessarily a good enough reason to be sending humans, because it's dangerous. However, there are lots of people that are very much wanting to go. So I think that also is something to take into account as well, people understanding the risks. But yeah, as Doug says, we're a long, long way off being able to send, astronauts any further than the moon at the moment. And even the ambitions there are vast and big, and are going to take a long time. So yeah, we'll see. But I do think, listening to some kind of Artemis podcast, was quite a few good ones out there, by the way, if anyone's interested. But just talking about kind of what kind of science you can accomplish by having humans boots on the ground versus rovers. does make some sense for sending humans to the moon. The moon's a lot safer though than sending them to Mars. So I think there'll have to be some improvements in that and lots of work done before we can be sending humans there.
Despite everything you read, we still don't know how to land humans on Mars because we're so heavy. We've done the little robots and rovers, but a crew, say a 4-person crew, that requires serious mass weight, if you like. And at the moment, we don't know how to land something that heavy on Mars. So whatever you read, we don't know yet.
So, it's kind of a risk-reward thing. It's maybe useful, but really, really hard. And currently, we're not there yet on that balance of, okay, do it, or even ability to do it, I guess.
Well, so Kennedy said all those years ago, we're doing these things not because they're easy, but because they're hard. Mars, very, 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 very hard. But maybe it's over to you, Evan. Think up some clever ways.
Brilliant. So, that's taken us right from the Apollo missions right to properly thinking about the future and actually getting some ambition and going beyond the solar system. But I think I just want to thank the Science Innovation Park for hosting us. Thank you all for coming and your questions, and people online as well. Thank you for joining in. And mostly I want to give a big thank you to Doug Millard and to Abbie. Big round of applause for them. And actually, my final thank you, because I haven't had a proper thank you all week so far, is to the guys behind all the tech that's made this happen, Amber Audio and OT House. So give a big round of applause to the guys behind you. So that's the end of this evening. People going on the tours, you've got amazing things in store. People online, thank you for joining us. And good evening, everyone. Thank you.